Okay, so we've got a new Z-test to look at here. The IOC states that female participation in the '04 Summer Olympic Games were 42%, even with new sports such as weightlifting, hammer throw, and modern pentathlon being added to the games. Broadcasting and clothing companies want to change their advertising and marketing strategies if the female participation increases at the next games. An independent sports expert arranged for a random sample of pre-Olympic exhibitions. The sports expert reported that 202 of the 454 athletes in the random sample were women. Is this strong evidence that the participation rate may increase? Okay, so here we go. We're going to test an appropriate hypothesis and state our conclusion. Well, to test the hypothesis, you got to do all of this stuff. We got to talk about all the information, stating the hypothesis in the meantime. We got to find conditions. We're going to have to do some calculations before we state our conclusion. So the first thing we notice is that P is 0.42 and Q is 0.58. P is from right there. It tells us that X is 202 Olympic women, females, and N is 454 random sample of Olympic athletes. So our P hat is 0.45. That's 202 divided by 454. Now, this is 0.4449. Excuse me, some people would say, oh, that's not 45. Some people would say, oh, that's not 44. I don't care. Use whatever you want to. I'm just writing that for right now. And that Q hat is 0.55. They accept that rounded either way. Now, here's the important stuff. The null hypothesis, H sub O, colon, please put a colon out of equal sign there, P equals 0.42, and my alternative hypothesis is P is greater than 4.2. And of course, alpha is going to be 0.05. So we look at, all right, so what are our conditions? Well, our first condition mentioned up here is a random sample of women, or a random sample of Olympic athletes. So random sample of 454 Olympic athletes. We know that 454 is less than 10% of all Olympic athletes. And then we find our NP and NQ. They're both greater than 10. Now notice this is P and Q, not P hat and Q hat. And so our conditions are met, and we're going to do a one proportion Z-test. One proportion Z-test. Conditions met. We've got our info. Let's do some calculations. First calculation I'm going to do is standard deviation. And my standard deviation is, it's like the big reveal thing, but I'm sorry, I've only got, whoops, you can't see it. Let's move that screen. So we have sigma, our standard deviation is the square root of PQ over N, and I'm getting 0.023. Then the next thing to find is our z-score. So to find the z-score, I went p hat minus p over standard deviation equals 1.076. Good night. Now, the thing is that where does that come from? Okay, well, if we go stat, go over to test, number 5, and we put our numbers in, then we go greater than because that was our alternative hypothesis, and then we calculate. These are the numbers that we get. Our proportion is, our P is that greater than 0.42. That's our alternative hypothesis. Our z-score is right there. Now, instead of me plugging in numbers, where some people use 0.45, some use 0.44, no matter what you used, all subtracted by 0.42, the calculator did all those calculations and they use all of the decimals to answer this with. So this is the most accurate answer. If you got 1.3 all the way down to 0.86, that's okay. That is okay. I'm going with this number though, and I'm moving right along with it. And so then my P is greater than, the probability of P being greater than 0.42 is the same as the probability of Z equaling 1.076, and that p-value is 0.141. Wow, look at that compared to that. Which one's bigger? Obviously, this is much bigger than that. So since it is bigger, our p-value is greater than alpha, we come to our conclusion. Here's our conclusion. The big reveal. With a high p-value compared to alpha, we fail to reject the null hypothesis. There is not enough evidence to show the participation rate may increase. Now, this last sentence came from right here. Is there strong evidence the participation rate may increase? To show the participation rate may increase. There's not enough evidence because my p-value was so much larger than my alpha. Okay, I'll let you leave that there, let you peruse that for just a moment. It's a simple 5.5 minute video. Hope you have a good rest of the day.